Good morning, or good afternoon for East Coast folks. My name is Mike Susek, and I'll be your host today. I am an elections expert here with the Elections Group. Before joining the Elections Group, I was a local election official going all the way back to 2004, always at the county level for a couple counties in Colorado until I relocated to my hometown in Pennsylvania, and I was an election official there for my last year before joining the Elections Group. So I am very excited to be hosting this discussion today to talk to you about generative artificial intelligence. So what is it? What is it good at? Maybe not good at? And how can election officials start to responsibly consider using it in their offices and with their workflow? For those of you who may be joining us for the first time, the Elections Group partners with state and local officials to implement new programs or improve processes for voters and stakeholders. We provide guidance, resources, and direct management support for state and local jurisdictions. And our team is made up of all former election officials and election experts from around the United States. We are very pleased to have you with us today for our July webinar, almost August, end of July here, webinar on generative AI or artificial intelligence. Our discussion today will be based on a document, Generative Artificial Intelligence for Election Administrators, an Introduction. This guide, produced in partnership with civic technologist Catherine Peters, serves as a comprehensive resource designed to help election officials understand and potentially integrate AI into their workflows. It offers a clear introduction to generative AI, explaining both its capabilities and limitations, and provides practical examples of how AI can be used in elections administration. The guide emphasizes the importance of ethical and efficient implementation and includes case studies, frameworks for deployment, and worksheets for planning and evaluation. So before we dive in, I'd like to point out that the Q&A feature is open for attendees to ask questions, and we have a dedicated Q&A section towards the end of the webinar. So if your question is not answered, we do encourage you to follow up via email. Our email is support@electionsgroup.com. All right, let's go ahead and get started. I am really excited to introduce our guest for today's webinar, Catherine Peters. So I'm going to go ahead and Catherine, hand it over to you and let you give an introduction.
Hello, friends. It's excellent to get to join this group, and it's excellent to get to work with the elections group. I'm Catherine Peters. I first came into elections as a graduate student doing a policy degree when a friend and classmate of mine approached and said, you know, I keep missing the opportunity to vote. Simple practical process steps keep getting in my way. And I'd like to build a reminder system that helps more people navigate that process. That reminder system that we built together became TurboVote, which was the first project of Democracy Works. And I spent 10 years helping voters navigate elections through tools like TurboVote, through programs like the Voting Information Project, and with tools like Ballot Scout. In 2020, I left that work and then went to the University of North Carolina, where I was the inaugural executive director of the Center for Information Technology and Public Life, supporting a group of researchers who study how our lives online and how our internet presences have really shaped our political discourse and our participation. I'm joining you today as a freelance democracy technologist, in effect, and I really loved getting to take the time to study these new tools, really think about their implications, and to try to bring some of that back to the election administration community. In today's conversation, I hope we can do some more of that bridging work that makes it possible for election officials to bring their expertise to these tools and really shape how they get used and how they get deployed for themselves, rather than having those questions answered by outside technologists coming in as experts in their field, but not necessarily experts in elections. So thanks so much for joining us today.
All right, great. Thank you, Catherine, for the introduction. So before we get started, and I'm going to hand this back to Catherine in just a moment, if she's okay with that, we are going to ask everybody to do just a little show of hands exercise. That's kind of a little warm up. So you can just raise your hand kind of, offline, just thinking about it. But I'm going to go ahead and hand it back over to Catherine.
Absolutely. What we're curious to know is, raise your hand if you'd agree with the statement. I'm completely unfamiliar with AI. I'm brand new to it. Or next, I've read about AI. I'm somewhat familiar about it, but I haven't really started using it in any detail. The next would be, I've researched AI, I've even started to use it, but I'm not using it in the official capacity. And the last would be I've researched, used, and implemented AI into one or several work streams.
All right, great, great. I hope that kind of got the served as a little warm up to get everybody thinking about, where they are with artificial intelligence. I know myself a year ago, it was just something I was generally becoming aware of in our popular culture and our news feed. And now it is, yeah, it's part of my workflow. It's something that I'm really interested in continuing to learn about. So I'm going to start off with our first question, Catherine, if you're ready to go for it.
Let's talk.
All right, so Catherine, your guide lays out 5 ways of looking at artificial intelligence. So I'm going to let's run through those 5 one at a time here. And so the very first one is artificial intelligence is a probabilistic content generator. I want to make sure I enunciated that correct. So probabilistic content generator. So what does that mean?
The problem is that those words are not very fun, but it means exactly what it sounds like. What makes this generation of artificial intelligence unique is that it is meant to be able to generate large amounts of text or images. And we'll talk primarily about text today, but that's why I use the word content rather than one of those. The idea is that it can create just huge quantities, and it does so using statistics. That's the probabilistic part. So, in effect, you take a huge amount of text, in this case, more or less the entire internet and history of human writing that you can find, and use it to teach a computing system how to create more text that can resemble what it has already been trained on. It looks at not just a word and its common proximity to other words, but the beautiful breakthrough in this generation of technology has been that you can think about multiple words together, clusters, phrases, sentences, and paragraphs, levels of proximity. And so it becomes possible not just to, in a very simple way that your phone will let you autocomplete a text, and from the word previous, it'll suggest 3 that might follow. These can now generate much larger quantities, and they do better because they can look at how clusters of words and phrases more commonly appear together or next to one another rather than individual word by word. So by and large, we've taken these systems and given them huge numbers of images, huge amounts of text, and said, okay, let's break this down. Let's study how they're built, what sits next to what. Let's distill all that into a complex mathematical model, and let's use it to create much more. So what they're really good at is creating text and creating images. And that's the core of what you're interacting with them to do. And obviously, we've seen them applied in a whole bunch of other ways. But if you can remember or distill it down to that as the fundamental thing they were initially trained on, it can help you think about what things they're going to be better at or less good at in a number of ways. For example, math isn't a word problem often, or mathematical computation is not typically written out in those ways. And so where we see that these same AI models are sometimes very bad at math, that's intuitively why, once you start to think about what's going on underneath the hood.
Great, great. I love one of the examples, maybe as a follow-up, one of the examples in the guide, when you're
Please
talking about
elaborate.
yes, when you're talking about these large language models and diffusion models, how they're able to, how this might affect what they're trained on might affect their ability to create new content. And you gave a great example of it might be really good at creating a picture of a person riding a horse, but not so great at the opposite.
Yes. If you've ever asked an image generator to generate a picture of a horse riding a person, you'll find that they don't tend to do it because there's simply nothing in their training data that suggests that that is a combination that they should make.
All right, great, great. So the second thing that you identify, generative AI, is that it is a chat-based user interface. So what do you mean by that?
I mean that we've all gotten really used to graphical user interfaces. You come to your computer and you have buttons, you have icons, you have images that tell you what they do and that you can interact with. You have text fields that suggest exactly what should get typed into them. We have a lot of structure that guides and supports us in using the tools that we use. We've gotten very used to those particular things. There's been significant amounts of research into how to help people use technological systems well using those visual cues. We all know on our phones that if we see a little icon in the upper right-hand corner with 3 little lines on it, that tapping that is going to get a menu. And that menu is going to tell us some words about other things that can happen. This is not that. Overwhelmingly, we interact with AI tools through an open chat. It's a blank box. It doesn't say much about what you should put into it. It doesn't have any cues or menus or any pieces. On the one hand, that's amazingly powerful. It's creative. This is where the concept of play really comes in a lot with AI right now, is you can try anything you want with that. And if you can figure out how to ask it, the tool will at least attempt to do whatever you've asked of it. It can also be really limiting in the sense that then there's no support for what's possible. There's no guidance, there's nothing. And even 2 people trying to do the same thing, by phrasing it differently or putting it in different terms, are potentially going to get very different results or outcomes. And so there's a whole new learning curve for how to interact with systems like that, how to support users on systems like that. And that's really, in the design field, a very new sort of piece of research that's underway, but is not anywhere near as well known as the decades upon decades of graphical support that we've all kind of come to know. So that's going to be a big piece of learning for people trying to adopt these tools, and most especially trying to take what they know how to use them to do and share that with other people, which is why the concept of prompt engineering, which is to say how to phrase the inputs that you give a generative AI system, is such a popular training course online, and why there are so many resources for trying to do it. We're all learning that together right now.
Thank you, thank you. And I'll just share, I did find in reading this guide that resonated with my own experience in just playing around, and yeah, I can't explain it without saying playing around with these tools and seeing what they can do. That yes, it was incredibly empowering, but until I stopped and thought about it, yeah, it was a little overwhelming because nobody was telling me what to type, where to type it, which button to enter. It was a very, very blank canvas user interface. It's a fascinating thing to learn. So
yeah.
All right.
It's part of why it's really important to start just by toying around before really trying to do any serious implementations, for sure.
Yes, absolutely. All right, our third, the third description is that generative AI is a mathematical summary of the web. And I'll follow up. Your guide outlines Ted Chiang's analogy of ChatGPT as and I'll quote, a blurry JPEG of the web. I love that, blurry JPEG of the web. Can you further explain, what this is and why it's important to keep in mind for new users?
Absolutely. And I will just credit it. Ted Chiang is a brilliant science fiction author, and in this case, explainer of technology. And I very much want to credit this notion to him. But he tells in this piece a history of photocopiers going from just directly photocopying images to taking digital images and placing them out. And that when they were taking those digital images, they were using JPEG, which is a common image format to do so. And they were trying very hard to keep those from taking up a ton of space. A photocopier doesn't have a large disk. And they found that there were infidelities, there were errors made in making those copies when they dropped information that turned out to be critical, particularly in the story that he told in architectural blueprints. And so what these tools do is very much like that. They've taken the entire internet, which is a very, very large amount of content. And they've taken a number of things that aren't just the internet, but the web is a good place to start. They've scraped Wikipedia, they've scraped Reddit. Famously enough, they've taken the contents in the archives of the New York Times, and the New York Times is suing some of these companies over that use. And they've taken all that text, and they can't use all of it directly in every single response. What they've done then is in distilling it down to build that model of what words most commonly fit next to other words and what sentences and phrases work together and don't. They've tried to distill that. And what they've done then is lost a lot. And so you don't have an entire Wikipedia article. You don't actually have the knowledge that was in that Wikipedia article. What you have is a mathematical summary of the word proximities in that. And so asking factual questions sometimes gets a very, very correct answer, because who was the first president of the United States has been asked and answered so many times. And the proximity that is going to be George Washington is going to come through very clearly. But when you ask questions that presume things that aren't true, especially, the models didn't keep the fact that George Washington was the first president of the United States. They kept this statistical impression of that fact. So you can ask things like, why do refrigerators only run in the winter months? And you can have the model start from those words and try to build a potential response that feels plausible and that completely misses the idea that that's not factual in the first place. And so when we take images, for example, on our phones, we pick that resolution. And sometimes you really want something that's very finely detailed that keeps all of the very smallest grains of wood in your image. And sometimes you really want something that can really get compressed down. And these models really compress that down. And so the way that Chang asks the question that I think is really relevant is sometimes what you need is an exact answer. You need the Wikipedia article. And sometimes what you need is a paraphrase, a brief summary. Accuracy isn't as critical. These are really good at that paraphrase. They're really good at that accuracy not always required kind of summary. But they're very capable of making up entirely plausible sentences that reuse the same content in ways that no longer match what we would call ground truth. The common term for that is hallucination. I personally don't tend to use it. That implies something about believing this content or knowing this content that isn't really what the model is doing. But they absolutely will make sentences that don't happen to be true, or they will create images that don't happen to be true. I think the example that we put in the report was that someone asked one of these models, Bard by Google, about details about the James Webb Space Telescope. And it said that the Space Telescope took the very first pictures of a planet outside our own solar system. And the idea that a telescope takes pictures, that it takes pictures of planets, that it's taking pictures of planets outside our solar system, that this telescope was a first in a lot of ways, are all quite intuitively true. But that particular first is not. And that particular first, when put together in that order, was simply false, and yet follows the math. And so you compress it all down, and sometimes when you try to fill the details back in, it looks perfect. And sometimes when you try to fill the details back in, you get some strange noise as well.
Excellent. Thank you. That's incredibly helpful way to understand it. So discuss a little bit about what it is. The next two items are, what is it that AI needs? So in the report, you identify that AI needs scale. So to elaborate a little bit, it outlines the guide outlines the importance of scale pertaining to artificial intelligence and how increases in available scope and power across really three key areas make these tools possible. So can you talk a little bit more about this?
The first one we've talked about a lot. It's training data. We talk about how large that data set is. This is maybe the biggest constraint on the future of improvements to these tools. They've already collected approximately as much text data as is available in the world. So identifying additional data to be used to expand or refine or make these models more powerful is proving to be a real challenge. There's an active discussion among technologists in the field about whether the future can be that they have the models themselves generate additional data that they then use to train it. It's called synthetic data. And whether that would be able to continue letting them build, or whether by doing it that way, they create negative feedback loops where quirks or shortcomings in the models make the data that they generate, the new text, in less useful in some meaningful way, that then when put back in, it actually doesn't enrich the models by very much. So there's a lot of unknowns there. And that's one of the big constraints on their size. It's also one of the reasons why we're only just seeing this technology emerging now, is that it's taken a good long while to get this much text available and digitized in formats that can go into this. So that's the first piece of scale that you need. The next is computing power that can be used to just crunch all of those words and build that statistical model in the first place. That's another major reason why we're only seeing this now. That's processing power. We've seen computer processors get radically more powerful year after year after year. That's one thing that may continue to improve. We may see that we're able to build more sophisticated models just through having more power to put at them. But that's also just a part of why we're seeing so few companies really building original models rather than refining them. It's a major investment. This is millions upon tens of millions upon hundreds of millions of dollars in computing power being used. And it's really sort of where we're seeing the costs of AI and where we're really seeing the consolidation of who holds this being kept to largely existing major powers in the computing field. And then the final one is a little bit of a quirky one. Once you're done crunching all that data, you get a lot of control as the designer of a model over how big the model itself is. You can say, okay, I want a really finely detailed model. I want it to have a lot of data kept. It's back to that analogy of a JPEG. You can have it be higher resolution or lower resolution. And those higher resolution models then can be more sophisticated, they can be more accurate, they can do a lot of things better. But then they continue to require significant hosting and processing power on an ongoing basis. Whereas you can start with that same data set and you can start with some of that same processing power to generate your model. And you can build smaller models that have fewer parameters. And in some cases, these may be less powerful, but in others, they may be more useful to a lot of other applications because they can be run on other smaller equipment. They can be run at lower long-term cost. If you're going to be refining one for an academic research purpose, for example, you may not want every piece of power that you can, but you may want to be able to host it locally at your university, for example, or in this case, as the elections community, to be able to afford to maintain one that is unique to elections and somehow distinguished from these others. It makes some of the ongoing costs of maintaining the system a bit higher or lower and play a big role in how it plays out as well.
Excellent. Thank you. Thank you very much. So the next item that generative AI needs in the report is it needs human input. I think it's an important thing to remember. These aren't just automated programs that are running on their own 24/7. It needs human input. And this is really one of our favorite points in the guide. So it does rely on human effort. And you highlight a couple items, data preparation, training, and oversight. So I want to talk about that a little bit, and maybe more specifically, what should election officials keep in mind about each of these elements when, if they're deciding to use AI?
Absolutely. I think the major reason to underline human involvement is that I think we all know that humans build most of the computing systems we use day in and day out. When, for example, a significant fraction of the world's business computers went offline last week, everyone understood that there was probably a human error or several going on in the chain at CrowdStrike for that to happen. That was not the computers taking themselves offline in some automated fashion. When we talk about AI, though, we see more and more that we talk about it as though the computers are doing things themselves. And that makes some sense. The word programming evokes something. The computer does only exactly what a human told it to do in a very specific computing language. And that if you understand that language, that programming language, you can go back and see exactly what the human told it to do. We can always understand it. And as we've started building systems that use machine learning, that phrase also evokes a certain sense that we've given it a lot of data and we said, this is what it does, this is what it doesn't do. And we don't always understand exactly why or how the computer uses those inputs that we've given it in the same way. Computers can now reliably recognize images of cats. We've given them lots of images of cats and we've given them lots of feedback about which ones are and are not cats. But what the computer is doing when you're doing image recognition and seeing a cat is not going, oh yes, it has the appropriate ears and the right face shape and a tail and like hair or not hair. It's doing something at a pixel level that does not actually make any intuitive sense to us as humans. And so we start to think that the computer is like thinking or doing, and we forget that by and large, it's still responding to data that humans gave it about these are pictures of cats and this is information about which ones are cats and which ones are not. And then you get to generative AI tools and it gets even more abstract because the amount of data we've given it and the amount of feedback we've given it means that at this point, no one comprehensively knows what the computer has or has not been taught by a human. And so you see stories like researchers saying that one of the AI tools was starting to work in a language that it had never been given in its training data. And that later turns out to be an accident. It was given that language and training data. It's just that everyone loses track of this. So data preparation is critical in the sense that we didn't just send the computer to go read the entire internet. Someone had to scrape all of that. Someone had to annotate that. It had to get cleaned up and processed. That's hourly work that's often done by contractors. Some of them are in the United States. Some of them are scattered around the world. And the decisions that they make about how they clean that, how they annotate that, which pictures get labeled cats, which pictures get labeled as other things, all shape what the computer then is, what the model, I keep using computer, but the model ultimately repeats back. And so those decisions have been made, and it's always worth remembering that when things come out of here, human decisions really played a part in that. That's just something to keep in mind. Similarly with training, what questions are expected to have what answers, what responses from the model initially got coded as correct or accurate or good or desirable, were all done by human decision making. And so what kinds of things it's good at and what kinds of things it's not are still design decisions made by people overwhelmingly in the Bay Area. And what it will get good at over time can still be shaped by people as well. Those aren't fixed, they aren't final. And then the big thing for the elections community to keep in mind is that that's an ongoing process and a loop. And so oversight is the place where it's really critical to think about humans' role, and especially our role as people who work on or around elections. So how do these things get set up? What kinds of questions are they given? What kinds of responses are used? What kind of review is given to those responses before they're used in any kind of setting and context? What kind of additional fine-tuning training can be done to really make the models better at or give them more accuracy in a particular field? And how do we deploy them? And so that actually then leads into the next set of questions, and that was sort of a pivot moment in the report for a reason. The tools are not fully formed. The initial responses you get from them aren't themselves final either. And so really taking agency and really taking the reins as we're deploying them is critical on an ongoing basis.
All right, great, thanks. And as you said, it's kind of a good way to segue into the next part of this presentation and the guide as well. So we've kind of gone over the background of AI, so I'm giving everybody a bit of a primer. The second part shifts gears and talks about how we might actually use it. So I'll just ask you directly two questions. It's flip side of the same coin. What is it that that generative AI does well, and where does it maybe fall short?
Truly, the word generative gives you a great sense of what it does well. Do you want to try to just make something, not necessarily from scratch? Asking a tool to help you start an initial draft, helping it iterate on different pieces, treating it as a creative partner as you figure out words or images or other pieces. It can be a really excellent place to noodle or to feel like you're not alone with a blank page. So getting out of a creative rut, it can be really fun. It can be not necessarily fun, but also just helpful. Say, actually on a conversation hosted by the elections group, had one official say, one of the things that I'm still struggling with, but that I really wish it would do, and that I tried doing with an image generator, was I love the civic icon library from the Center for Civic Design. I love that particular election tools resource. I realized I wanted an icon that matched them, but that showed an image that didn't exist in the icon library. And I thought the tool could generate it. I haven't gotten it to do it yet, but that concept of, I have a visual language, I'm not a designer, I have a need, those kinds of places to be able to not necessarily play in this case, but to experiment and to sort of test can be where it's really helpful. Similarly, they can be good at summary and synthesis. You cannot guarantee absolute accuracy, but taking large bodies of text and saying, can you show us a point or two? Can you show me what the major themes or takeaways are? You can get good insights. And so it's certainly not a substitute for reading through critical documents that you need to read, but it can be a great getting started point. Mike, I believe you were one of the ones who helped look at using it as a tool for taking responses to an RFP and helping get some initial bullet points to go through. And that sort of first summary can be really good. Do you want to say anything more about that as a use?
Yeah, sure. And also, I will reiterate what Catherine said, that, this is, it's not a substitute for reading a full RFP. Of course it's not. But what we did, just kind of playing around, was what would happen if you think to being an elections administrator, and maybe you're going out to bid for something and you have a couple RFPs, and one RFP and a couple of responses to it. What it was really good at is asking it for, hey, can you give me a summary of these three RFPs? And specifically, can you pull out, can you highlight these things that we're particularly interested in as criteria in our RFP? Of course, you still are going to go back, you're going to read the RFP, you're going to do your full analysis, but it was really great to have this summary sheet that you could use just as a reference in between reads.
Yeah, absolutely. Similarly, it's great at generating sample data in a lot of settings. So you can say, okay, this is the data structure that I have. I need lots of names and addresses, first, last, street. And I'd like it to come out in this format. And you can generate lots of fake data. And so sometimes when you're testing your systems and what you have is real data, but that would be sensitive or protected and you don't necessarily want to use it, this is an easy way to generate large volumes of artificial data that may be structured correctly, that may work well, but that is not using, say, your actual voter file for things. So that can be helpful in a number of settings. And then I do note play, but we've talked about that enough that I think we'll stop sort of there. But just beginning to get creative can go a really long way, for sure. And then you also asked about it falling short. Mm-hmm. Putting chatbots out directly to the public is still a place that can run into all kinds of challenges unless you're really, really careful at how to support it. For a couple of examples, a number of automobile dealerships were using AI-supported chatbots. This one ended up not being a huge problem, but the internet decided to begin interacting with these particular chatbots, which hadn't had enough guardrails placed on them. One person demonstrated that they were able to get the chatbot to offer them a new vehicle for $1. Obviously, that wasn't a legally binding offer. They were not able to buy the car for $1. Someone else got it to offer them coding assistance and advice. They were doing a number of things that no car sales chatbot should have needed to do. Simple mischief is simple mischief. Similarly, though, the city of New York had released a public-facing chatbot intended to help small business owners. It provided advice that was, in fact, illegal. And if had small business owners relied on its advice on how to share tips with their employees, which they aren't allowed to do, or how to evict residents who relied on public assistance to pay their rent, which, again, very, very illegal, they could have gotten into pretty hot water with the city, which was presenting this chatbot as an authoritative source of advice for exactly these communities and where some of these questions were very much intended in the spirit of what the chatbot should have been able to answer. So that's one really tricky place because, again, correctly formed answers are not necessarily the same as a directly true answer. So the amount of additional training and the number of additional guardrails you have to put on to sort of limit off-topic engagement or incorrect engagement is really high. Accuracy remains a challenge. I think the last accuracy piece that we would talk about, other than plausible or not, is that the word not itself, negation, can be one of the things that really can trip up a bot. Tell me some things about this. What is it? It can answer very well, but sometimes when you say, what is it not? That word does so much in our language, some of which is captured in a statistical model and some of which isn't. You'll often see that give me not that can get you into some really weird answers. Most entertainingly, if you take an image bot and say, for example, give me an image of a room without an elephant in it, you will get some very interesting images of elephants. So that can be very fun. And if you're curious about how that plays out in election context, the AI Democracy Project at Proof News did do a test using a number of election experts. I don't know if any of them are in this room today or not, but asking all of the common chatbots, all of the AI chatbots, a series of standardized questions about voting, ranging from can I wear a MAGA hat to the polls in this state to where do I vote within this zip code, and rated that about half of all of the answers were just inaccurate based on what the models had as knowledge. Additionally, you get bias. I think that's been talked about in a lot of other settings, so I don't plan to elaborate on it much here. Mostly that's a product of remembering humans designed this and we have our biases. But the last thing that's sort of unique to these is that in many cases, when a technology fails, you get an error message. You see, I can't produce that. That web page won't load. 404, file not found. You get this process is canceled. You get timeouts. You see something went wrong. Because these bots are designed to generate, but there's no way of checking if what they've generated genuinely responds to the prompt or not, you will almost always get something. And whether that something addresses the question you put in is actually yours as the user to address. This is back to a little bit the challenges of a chat-based interface. But if you're not looking carefully, the fact that it will give you a correctly structured answer may be misleading. So that's a kind of a silent failure, and it's a new way that the technology can go wrong that we have to get much more attuned to when we're working with these tools than necessarily the kinds of interfaces or the kinds of tools that we've been used to in the
All right. Awesome. Thank you so much. All right, I got one more question, and then I'll give you a little break from talking, and I'll chime in for a little bit. So,
past. Great.
so let's talk a little bit more about specific election administration uses. There's a couple that you highlight in your guide as coming up quite often. Drafting social media and press releases, locating polling place, and also translating materials. I don't know if you wanted to elaborate on any of those, or maybe what are some other ways that election officials can be using AI?
Yeah, I think so. Those are ones that let's say that probably the Brennan Center found that people are actively already using it for, which is amazing. I actually think that locating polling places is an excellent one in the sense that um, finding potential locations is a constant challenge, and so being able to ask an AI system that may have comments from the web pages of all kinds of small businesses and community centers and other things from across your area, being able to say, okay, I'm looking for locations, buildings that have these particular features. I'm looking for businesses that might do A, B, and C, and having that be able to help, again, imagine potential places to reach out to as polling location partners is a really fun one. It's that equal parts creating raw ideas that you're still going to need to check, but also helping get outside of necessarily the exact parameters that you've had and take some of that information that's available. So wouldn't have thought of that one. I'm really pleased with the 2% of election officials who've tried that already and who told Brennan about using it that way. I think that the places that it may be most useful are still going to be discovered, though. I think right now what we are seeing is an election community that has its early adopters and its creative minds taking what we already know these tools are good at in other sectors and trying to apply it. So that initial generation of ideas, that initial generation of text and images. And so drafting social media and press releases is a natural piece. Drafting RFPs or summarizing pieces are great. I think there may be ways to use it to make poll worker training more interactive that involve not open-ended chatbots, but making some of these pieces more engaging and more interactive than they have been, and not necessarily having to be just a person. Being able to take those training materials and make them available as a chat enabled tool could go a long way. I think eventually it could be a support for direct voter engagement, though I would really want to see that tested before it goes out. I think right now we don't see that the technology is ready for that. And so then I think the places that we'll see biggest breakthroughs are in that creativity and play kind of space. It may be that it is in helping take what we know about election administration and speaking it out in meme formats that make it easier to engage with younger voters or older voters or voters in different cultural contexts. I think just translating is one thing, and I think these tools are moderately good at that. Getting things not just word for word translated, but really transposed to feeling authentic and being well spoken to different communities is a whole other variable. And these aren't necessarily there yet, but there may be some really creative ways to be able to do that and to meet more people where they are with them. So I'm not sure where it's all going to go. I do think that approaching it with a spirit of open creativity will be helpful, and I'm excited to see more people trying things. So.
All right, fantastic. All right, so I'll give you a little bit of a break as we head into the home stretch here. So I want to discuss the elections group. We have published a document called Artificial Intelligence, Primer for Elections, a primer for election administration. And this does kind of explore a little bit of some of those use cases that we've played around with ourselves. So some things that we found that it was good at, and I do want to give the disclaimer, all of these tests were done with publicly available information. These are all things that we would recommend playing around with first, and of course, doing your homework, doing your proofing, making sure that using these tools, these aren't going to generate your final work product that you're just going to hand off to the public. These are productivity tools. So one of the first things that we found it was really good at, as Catherine discussed, was just communications. It was fantastic at drafting content or drafting, even more simply, drafting outlines. Like if you're hitting that creative rut and you need to get started on a project, one thing that I did, I thought of a real life situation where maybe about 10 years ago, I had a council member come to me and they wanted to report on, they were interested in ranked choice voting and they wanted me to write a little summary of it. So I just kind of thought back to that moment and like that how do I get started moment. So I used ChatGPT and I just asked it a couple questions. Can you write me a summary of what are some of the key points for, that I want to think about for ranked choice voting? And lo and behold, it actually came up with a pretty good summary of here's some topics that you may want to research and discuss. Again, not the final product I'm going to hand off to the council member, but it did get me kind of that like 60, 70, 80% of the way there to getting rolling on the project. As we discussed before, we found that it was good for in budgeting and procurement, that concept of summarizing and maybe even analyzing RFP responses. So we've discussed that already, so I won't really go into detail. One tool that we think has some great potential is ballot proofing. We know that every election cycle there are countless headlines and countless hours and the costs of reprinting. Ballot proofing is a painfully human process, and it will always be a human process. But we found that artificial intelligence was a tool that we can use. So what we did is we found a publicly available file from the Secretary of State's website of the official list of candidates for a governor's race. It was a spreadsheet file. Then we went and found a sample PDF of what that sample ballot looked like. This was for a previous election. So we took that Excel file and we purposely went in and made a couple mistakes. We changed around, we made some typos in the candidates' names, we added a candidate that wasn't there, and then we uploaded it to ChatGPT and we asked it, can you help us proof these? And we gave it some specific things to look for. Can you look for typographical errors? Can you look for missing candidates? And it did find those errors that we made. So not that would replace the human proofing process, but I think that showed us just some great potential for how you may think about incorporating it into your proofing process. Another thing that we found it to be good at, it can help assist with analytics. And one thing that I like to do is love playing around in Excel, building charts, building graphs. But I will fully disclose I'm awful at using Excel and Sheets to make histograms, bell curves. They just never really come out the way that I want them to look. And I found that I was able to provide a voter history file and publicly available, give it some parameters and give it, set up some parameters in a prompt. And it did create a histogram for me, which actually, upon verification, was accurate. So it just has some potential uses like that to play around. So just a couple things to be thinking about. So let's see here. I'm going to hand it back to Catherine with a question, and then I see we'll open up the Q&A and get to that in just a moment too. So Catherine, we're going to go back to you here. So your guide also highlights how teams can use design research for teams who are beginning to imagine additional uses of AI. Can you talk a little bit more about this and something in the guide that you call the importance difficulty matrix?
Absolutely. So in design research or design process and ideation, an importance difficulty matrix is a really common prioritization tool. If you have a set of ideas that you want to be able to really schedule or project plan around, it's a way of working with a team to rank them first from most to least important. And you sit down with the group of stakeholders that you need, and no ties are allowed. They have to be ranked absolutely first to last. And you can hash out why, and those conversations can be a really important way of understanding the team's needs and values. And then once that's done, you also want to rank them from most to least difficult. And again, no ties are allowed. You have to sort of hash out why and what's going on. It surfaces a lot of assumptions about the work and what's going on. And those come together. And ultimately, what you end up with then are 4 quadrants of a chart that suggest like high importance, high difficulty things are strategic priorities. You may need to break them into smaller pieces. You may need to schedule them. They might not be the very first things you start on, but they need to happen, and they're going to need some resources. The things that are important and less difficult are the easy wins. Just go for them. Like you absolutely want to start with those immediately. Some of the things that land in the less important, some of the ones that are less difficult, may be opportunistic things to pick up in between spaces. Some of the ones that are less important and very difficult may be worth deprioritizing, backburnering, setting down, entirely or otherwise breaking down. But when we're talking about AI, we're not necessarily starting from a collection of planned projects. The way we can use that matrix is to reverse it. We can imagine first, what are our top priorities in the space? And then once we've thought about what's most important to do at all, we've generated the cards that we know would land there, we can ask the question of these priorities, where might AI help? Where could it potentially make them less difficult? Where could it support them? Similarly, we can start with what are some easy wins in our office that we imagine the technology might fit for, where deploying it would be really simple. What are some places where we might play or experiment, where it would be simple to test it out alongside our existing work and learn some things, and then imagine it. So using that matrix in reverse to try to generate ideas that might sit in those quadrants might be one way to sort of surface what your team wants to play with or wants to prioritize experimenting with. If you're starting without very many ideas about what to do, some good questions that you can ask then are, what are the 5 biggest things I'm trying to accomplish in 2025 first? And once you really know that, then the second question can be, are there any where I can imagine these tools helping me accomplish that? Are there any that seem like they might be fits based on how I understand the tech? Or similarly, what are some things that would be really fun to try or some really easy wins that I would enjoy? And again, can the technology advance those? Might just help spark new ideas. So the hope there, and there's some worksheets at the very end that ask some of those questions. There's some of the strategic priorities and obvious wins and luxuries, but really identifying what's important and then thinking about easy experiments are two sets of questions that you can ask yourself to just start generating ideas. And you can ask them by yourself, and you can ask them in communities like this one and in conversation with other election officials. You can ask them with your staff or with other folks in your county or town who are thinking about it in other contexts. And those can really help get you started identifying potential implementations from your own expertise and from your own needs, rather than just starting from what the conversation about the technology is doing right now out in public. Because you do have your own expertise and you have your own knowledge, and using those as a starting point is really critical. You don't have to wait for the technology companies to tell you what to use these tools for.
All right, thank you. So since we're going to be bumping up to the hour before too long, so I want to make sure we get 1 or 2 more important questions in here for you. So one, we've talked a little bit about what it doesn't do well, but maybe we could hone in a little bit upon risk. So, your guide discusses how election officials can assess the risks associated with using AI. Can you maybe talk a little bit more about that? Is there anything else that election officials can do to mitigate some of that risk?
Absolutely. I think this is a place to talk about. There's an academic report that addresses the idea of marginal risk when talking about AI systems. And they were talking specifically about open AI models versus closed. But I think it's really helpful. Election officials already mitigate many, many risks. And there are just so many things that can happen in these places. So one of the good questions is, does adding this system increase the risk in some way? Does it make it more likely that something will go wrong? Does it make it more costly or more harmful if something does? And where the answer is yes, then that's a good place to hone in. Because otherwise the number of potential risks to consider is just far too large. And then in thinking about mitigating, there's an excellent report, again, out of the Brennan Center. I'm a huge fan of theirs. It's a multi-author team, but it's led by Edgardo Cortez. And they use a model they call CPR, choose, plan, and review, as a step-by-step system for thinking about those risks, identifying them for a specific system, and then mitigating them. And we've taken in this report that model because it's amazing and I endorse it. And if you're going down this path, you should absolutely read that report as well, but breaks down some fairly specific questions. And so at that plan step, thinking about mitigation, the questions are, for example, have you and your staff sat down and talked about the task that this tool is going to be performing as you deploy it? What is the process that you currently use to do so? What is the data that's going into the tool? What are the expected outputs that it's going to do? What are the common then risks that could happen? So is accuracy important here? And if so, how are you regularly checking that accuracy? Is it not? Is this just a starting place? And so doing that once at the outset as a planning step can help you think about what kinds of ongoing review you're going to need and where you don't. And so the answers will be quite different for one versus the other. If you're using it to create that summary cheat sheet for an RFP, the answer may be it's creating us a summary cheat sheet, and the process is that we're going to feed them all in and ask it for some bullet points. And the only data it's getting are the RFP responses. So there's not really privacy issues. There's not really voter data touching it. The expected performance is that it will create the summary, and the only real known risks are that it could misconstrue some of the proposals. It might miss some important points. And so what we will do is we'll have that cheat sheet there. And when we do the in-depth review, we'll go ahead and confirm that all those pieces are accurate. We'll correct any inaccuracies. And then at the end of that, we'll have our quick at a glance sheet that we can come back to over and over again, knowing that it was automatically generated, but that we checked it at the one moment in the process where we needed to, and the risk is fully mitigated. Versus it's a very different piece if you're using it to work with voter data or to work with something that's much more public facing. You might come to different answers, but it's a good way to know which use cases are in fact very low risk, which many are. I know we've been talking about the more serious ones, but sometimes you can walk through that checklist and go, okay, great, we're in play mode. Nothing can really get hurt. The risks are low and we can mitigate them. So,
all right, fantastic. So one last question, or maybe one more thing we want to point out in the report, and then I know we have at least one question coming through from the audience. So let me just the end of your report ends with a series of worksheets that are available to election officials. So I'd like to share that these templates can help election officials work through their existing processes and procedures to see where AI might fit into their workflow. And I don't know if we're able to share those on the screen or not, but if you're able to maybe just, and if not, maybe just briefly walk through those, and then we'll hit the Q&A.
Absolutely. Hopefully we will. I think the first of those is that ideation. So what are my top 5 challenges? What are my highest priorities? Where are there tasks or processes that are really feeling effortful or time consuming for myself or my team? Where do we need support? Those are ways to think about potential use cases, where to begin. And then once you've kind of picked a use case that you'd like to, there's a worksheet on, for example, identifying the core requirements. So the first piece is to just describe what the process is. And the one on the sample worksheet in the guide is comparing ballot design against documentation of requirements for completeness and accuracy. Mike, it's exactly what you just described doing. And the neater goal is that we'd like to be able to provide our staff with a second pair of eyes, that they're going to be the ones doing the first review, but let's duplicate that up. It can never hurt to have more types of review. Let's add some redundancy to our process. And the inputs we need then are like, we need those ballot images. We need the lists and candidates in spreadsheet form. We need the formats. And then what are we going to use it for? Like, how do we do that? And then we say, okay, we're going to ask the model that precinct by precinct, we want to confirm that all the applicable races and candidates are there. We want to confirm that the layout complies with all of the state-based requirements. And so what do we want the system to output for us? And we want it to just give us a list of errors or omissions or a confirmation. And that way you sort of started by going, okay, what is it doing? Does this work? And then you can start then on those following worksheets. Once you've identified those core requirements, you can ask questions about, could this process shape decisions that affect a voter's ability to cast their ballot? And the answer is like, yes. If this finds an error, we would change our ballot layout. If this tells us there are no errors, we may be slightly less vigilant about finding any ourselves. How could variations in the performance cause harm? Say we use it a couple of times and it's really helpful and it catches everything, and then the third or fourth cycle through it, it misses something critical. Will we have gotten complacent in our human review? Could inaccuracies or unreliability pose threats to voters? Could it introduce bias? Ballot proofing, it might not be able to introduce bias. It might tell you that certain like candidate names are the names themselves are wrong, even though they're correct. They're unfamiliar names to it, for example. And so those questions then help you address the question of what is the risk? Where is the risk? And then moving forward from there in planning, once you've kind of asked those questions and you've identified if there are risks, being able to figure out how you can address them. So again, identifying that there are risks isn't necessarily a stop everything, do not deploy moment, but it is a moment to say, okay, what staff are using it? How do we make sure they don't get complacent and stop acting as the second pair of eyes? How do we make sure that the AI system for that ballot review doesn't become the only pair of eyes on it? What happens if someone is using it and they realize that the AI system failed and made a mistake or an error? How do we make sure that we don't just have the human review move forward and we never make the system any better? So And then finally, there's that once we've put it in place, how do we review it? So those worksheets are there. And again, the kinds of responses that you'll be putting into them may vary a lot based on the particular use cases you've got. But once you have some uses in mind, they really create a space where you can think in a really structured fashion through that, following the recommendations put out by the Brennan Center that were just incredibly useful.
All right, fantastic. So let's hit up the Q&A here. I know we have at least one question, and if anybody else wants to throw a question in, so I'll go ahead and read it and give Catherine an opportunity to respond. So you mentioned there are instances where generative AI models may generate flawed results, like when you're talking about handling tips or giving tips about evicting renters. Yeah. Are there signs we should be looking for that would kind of tip us off to that sort of behavior if we are trying to use these? What sort of guardrails should we be thinking of? And is there ever going to be a point where we maybe don't have to have a human review of everything?
Yeah, I think that's very much what those planning questions are excellent for. Because one of the questions is, for example, actually, it's not one of the planning questions. Where is it? It's one of the early ones. It is in the choosing guidelines. I apologize. But like, could variable responses to similar prompts or inputs pose different risks? What would those look like? Sometimes the answer is no. Sometimes the answer is that we're using it to, like you said, outline an initial guide to some things, or proposing some thoughts about what to say about ranked choice voting and what's out there. When it's a starting point from there, and a person is going to take that and be building from it and creating it, and the ultimate thing that goes out is entirely human generated, it might not matter very much at all. If it is being used in that spirit of, I need some new icons and I'd like to create a few that don't exist, and they either look good and match the styling that I want for my purposes or not, some of those things that fall short in terms of accuracy might not play any role at all. When it's make me a limerick for National Voter Registration Day, probably not putting factual information in there to put it on your social media. And then when that is the case, I think that next set of questions in planning that are things like, who understands what the outputs are supposed to be? Then there may always need to be a human in the loop. For some of these uses, there always should be. I think that the guideline that Cortez and his co-authors put out is, if the system is doing something or affecting a process that could limit someone's ability to vote, you probably need to be forever vigilant. There's no way that you should ever just delegate that to a computing system and not be checking it. But you can delegate it in ways where it can still do a lot of the, say, effort work or the time work. And as long as what you've got is good training for people, it may still be hugely useful. And that human in the loop forever isn't necessarily a bad thing, or isn't necessarily a sign that the tech isn't helping. There may be uses where it's carrying a lot of weight, but that care and that vigilance is not a sign of technological failure, but is the fact that these are all support tools. And as much as we rely on them, we sometimes forget that they're support tools and that these are ultimately human processes and human decisions.
All right. Fantastic. Well, Catherine, I don't know how we did it, but we are like seconds up to the hour. So great job on timing.
Hey, we had fun.
Yes. Yeah. So I'll just wrap up and say thank you to everybody, especially Catherine, for joining us today. I thought this was a great discussion. The resources that were mentioned in today's discussion have been placed into the chat. As always, our inbox is open. If you have any additional questions, you can email us at support@electionsgroup.com. So I think that's about it. So thank you, Catherine, so much. And
thank you, Mike.
We'll see everybody next time.
Wonderful to get to work with you. Thanks, everyone, for joining us today.